The story of Ethiopia's struggle through drought and famine and its remarkable turnaround through large-scale soil conservation and water harvesting is now well known. Tigray regional state in the north was both the hotspot of drought, famine and hunger in the 1980s, as well as a hope spot demonstrating the potential of water harvesting in the decades to follow.
So everybody knows, like from the experts up to the decision makers, they know that the changes are very positive. But it's not scientifically measured. Now it's time to do more research.
Recognizing this need for data and evidence, the EU-funded WAHARA project set out to test select water harvesting technologies in 2011. This effort was implemented by Mekelle University in Tigray. Various stakeholders like the regional government, farmers, pastoralists, universities, and research institutions identified 4 specific technologies with high potential. For 4 years, these technologies were implemented within the Gule watershed, the test site, and their effects on soil health, water availability, yields, and livelihoods were observed and analyzed. 9 percolation ponds were constructed within the test site. Discharge of the springs downstream was measured systematically for 3 years. The results establish that percolation ponds can play a key role in rejuvenating groundwater sources like springs. The NGO Relief Society of Tigray, Wukro St. Mary College, and the Tigray Bureau of Agriculture partnered with WAHARA to set up 15 check dams around the test site. This included gabion check dams built to rehabilitate gullies formed due to erosion, as well as check dams built across streams to create water storage. Apart from storing water and rehabilitating gullies, these structures were found to be contributing significantly to shallow groundwater recharge. This was evident through increase in shallow groundwater levels in hand-dug wells downstream over 4 years, despite a general reduction in rainfall over that period. The WAHARA project monitored the effects of bench terraces in various topographical and hydrogeological conditions in Tigray and also in other parts of Ethiopia. The exercise showed that when bench terraces are designed in integration with a water source, they can be one of the most effective ways to create new cultivable land and increase productive rural employment by distributing the new land among women and the youth. The WAHARA study shows that the relatively high costs of creating and maintaining bench terraces can be offset by using them to grow high-value crops and by using water-efficient irrigation systems. The WAHARA research also focused on soil fertility management, as soil fertility has implications for agricultural water use. Various varieties of organic fertilizers and inorganic fertilizers were tried out in growing bread wheat. The results show that a combination of organic fertilizers and inorganic fertilizers infused with effective microorganisms helps achieve yield increase and at the same time maintain soil fertility. The water harvesting technologies selected and tried out in Ethiopia were large scale. Even experimenting with them under the WAHARA project required support from the regional government, farmers, pastoralists, universities, and research institutions. So their implementation, management, and success in the long term will be as much a matter of science as it will be of mobilizing individuals and institutions to make collective decisions and work together.